Saxon's Trig lesson 32 on page 219 is about inverse functions, the four quadrant signs, which we've actually already talked about, and inverse trigonometric functions. In section A, this inverse function, they go through trying to explain it with the function machine. I find it so much easier to just tell you that when you are doing the inverse function, you are basically flipping it around. So where you had a y, you're going to put an x. Where you had an x, you're going to put a y. So if you look at example 1 near the bottom of 220, it gives you the equation y equals 2x plus 3. And it says find the inverse function for that. So we're going to flip the x's and the y's. So where I had a y, I'm going to write an x. Now where I had an x, I'm going to write a y. And then when I'm solving for a function, I need to isolate the y. So now we're just going to solve the problem with algebra steps and solve for this y. So if I leave 2y on this side and I move the 3 over to join this side, it's x minus 3. Now I flipped the sides, but I didn't really move the 2y. I just rearranged the way I wrote it. And I hope that that is not confusing as you do these inverses. So the 2y stayed on its side and the 3 moved, minusing it to join the x. I didn't move the x, so it remained positive. So I've not broken any math rules. Now to get the y alone, every part divides by 2, and we simplify it. Y equals, this can be written as x over 2, or we can write it as a half x because there's an implied 1 for the numerator, and then the x, instead of being in the numerator, moves to the side, minus 3 halves. Same thing no matter which way I'm writing that one. And I have accomplished what they wanted. I have done the inverse, and that is the equation for it. So again, I don't understand why they go through that function machine to try to explain it. Example 2, find the inverse function of y equals negative 2x plus 5. You're going to flip the x and the y to do its inverse, so x equals negative 2y plus 5. Again, I'm going to leave this negative 2y on that side, and I'm going to move the 5 so it becomes x minus 5. And divide everything by negative 2. Simplify it. Y equals negative 1/2 x, and negative over negative becomes positive, and then we keep our 5 halves. And that's the answer to example 2. They also show you what the graphs look like. It's helpful to take a quick look at how they are changing those in those examples so that you get the idea of there is a mirror image that they are basically reflecting over, and that mirror line is usually y equals x. It's very rare that that changes. And you can see how the inverses have flipped around that mirror image line. All right, part B is the four quadrant signs. Now, I did this the other day for you, and I said I was doing it a little bit early, but just as a quick review then, the quadrant 1, quadrant 2, quadrant 3, quadrant 4. The signs in quadrant 1, x is positive, y is also positive. Quadrant 2, x is negative, but y is positive. Quadrant 3, x is negative, y is negative. Quadrant 4, x is positive, y is negative because it went down. And how do we remember which words in sine, cosine, and tangent are positive and negative in these four quadrants? Well, we're doing that all students take calculus as a reminder. So here, everybody's positive, sine, cosine, and tangent. Here, only sine is positive. Here, tangent is positive, and here, cosine is positive. So the reverse is true, that in this quadrant, cosine and tangent will be negative. In this quadrant, sine and cosine will be negative, and in this one, sine and tangent will be negative. Now that we've reviewed that, they move on to section C, what happens when we inverse trigonometric functions. So the inverse, and then they break it down. So they want to do the inverse of cosine, which is, as we've just said, the inverse is where we are flipping the x and the y. Oh, and I was looking at my note here in this lesson. I'm going to get to their specifics when I get to the example. So you need to understand that if I am graphing a triangle, I can either graph it in the first, second, third, or fourth quadrant, but I can also wrap multiple times. So when I begin to talk about the inverse, because I don't know specifically what they're asking me for, it could be wrapped 15 times. We are going to set a limit to keeping it as close to its original as possible. And I will sketch in quadrants 1 and 2 only, with rare exceptions where you might have to make a change. But in general, if you keep it to those, you will be fine. All right, they do the same thing when they are doing the inverse of the sine function. They give you a lot of the triangles and they're trying to do an explanation. And then they do the inverse of the tangent function. Now, tangent, I think we've said this before, maybe not. If this is the first introduction, tangent stands for sine over cosine. So when you are doing the inverse of that, you're going to be flipping that over, and so the inverse tangent is going to be cosine over sine. All right, they do their triangle explanations here, and they finally now get over to example 3, where we're going to explain what they took several of those pages there to explain. Now, I also want to state that when I said this is inverse tangent, that's that -1 that you were using on your calculator to get degrees spit out. Okay. So example 3, evaluate arc sine of radical 2 over 2. So when I see the word arc, I know that I need to give a degree answer. That's what this is asking me for. How many degrees will I graph if I have this? Now, sine gives me opposite over hypotenuse. But I realized that this is something that has been adjusted so that the radical was not in the bottom. And after you do a couple of these, you begin to recognize them on your own. So we need to undo that before we can actually begin to do the graph. So I would say it this way. Root 2 over 2 was the answer. I multiplied it by something, and I know that what I used, this, to fix had to be multiplied by 1, so that was the root 2 over root 2. So you're kind of working your way backwards. What do you multiply this by to keep it this? Well, that's a 1. And what do you multiply root 2 by to get it into a 2? Oh, well, that's a root 2. So the unfixed version is this. So this is actually, my opposite is 1 and my hypotenuse is root 2. And you need it this way because of the memorized special triangles that we've done. So I don't know which quadrant I'm supposed to be in other than using the fact that this 1 over root 2 is positive, and I said I'm either going to graph it in the first or the second quadrant. Since this is positive, I'm going to graph it in this first quadrant. And I don't know this degree. That's ultimately what I'm looking for. So the opposite is a 1. The hypotenuse is root 2. And when I memorize, that means this is also 1 because it's the 45, 45, 90 triangle to get me that root 2 there. So I know that this then degree has to be 45 degrees. And I could be wrapping, I have no idea how many times, but the basic, most simplest version is 45 degrees. Now, example 4. Arc tangent of -1/3 root 3. Okay, I see immediately that I need to fix this into one fraction, not a complicated one, so that I can identify my parts. So this is actually getting -root 3 over 3. Oh, okay. Is this one that was adjusted and fixed like this one? Yes, it is. So I know that this is going back to 1 over. So what did you, for this to be the answer, what did you originally start with? And you were multiplying with root 3 over root 3. And you get to where you don't need to write this out each time. You know that this is going to be 1 over root 3, because root 3 times root 3 is 3. So now this is my tangent, TOA, opposite over adjacent. They're positives, so I'm going to stick to this first quadrant. My opposite is 1. My adjacent is root 3. Do I know what that hypotenuse is? Yep, that's special memorized at 2. And what degree then in the special memorized, I know it's a 30, 60, 90. Which one is opposite the 1? 30 degrees. Now, oh, wait 1 second. I forgot to move this negative over. I should not graph in this quadrant. So this is actually negative. All right, so let me just regraph it. It cannot be, oh, hold that thought. All right, we were saying that I failed to put my negative over here. And so I'm figuring out which quadrant I'm going to graph negative for tangent. So since my all students take calculus is telling me where my positives are, I will not graph it in the all. This is where it's, so I can graph it in quadrant 2. I could not graph it in the tangent one where it's positive, and I could graph it here. And this is where I said I tend to stick to this quadrant. However, to one or 2, and then I would do 2. However, in this case, I will dump it down to here just because this is tighter to the edge of the 360. And I'll actually do both, and then you can kind of see. So let's relabel that in this case, opposite will not be -1. The negative will attach to the adjacent of root 3. So this is negative root 3. This would be +1, hypotenuse of 2. This is still 30 degrees in here. And so my answer would, if I go from 0 over, I'm shy of the 180 line by 30 degrees, which would give it 150 degrees. If I do in this quadrant, then my opposite is the -1. My adjacent will be the +3. Hypotenuse is always 2 here, and opposite this is still 30 degrees. So if I go from 0 backwards, I can write the answer as -30 degrees. Either one is going to be good. They tend to go with whichever one is closer to the 0 as their answer. Example 5. Cosine of arc tangent of -3/5. And they have to, because this is one concept, they have to put it in a separate, not parenthesis, but bracket or brace, so that I can tell the difference in all of the parts. So we always work from the inside piece outward. So this cosine will be the last thing I deal with. So I'm going to begin with which quadrant should I graph tangent to be negative? Well, we just figured that out, and we figure let's go with quadrant 4 because that's what we did last time. So my opposite, opposite will be the -3, adjacent will be the 5. That is not a memorized triangle. I can Pythagorean theorem to find the hypotenuse. Do I need to do that? Now, this asked for arc, which means degree, but ultimately I want the cosine. So I'm looking for the adjacent over hypotenuse. So if I just find the hypotenuse number, I don't really need to stop on my calculator and get the degree because it's not my final answer. I don't really care what it is. I just want to get to this. So Pythagorean theorem gives me 5 squared is 25, -3 squared is 9. That's going to be 34. So square root of 34 is the hypotenuse. Then the answer for adjacent is 5 over root 34. And do we want that root 34 in the denominator? Nope, so we're going to have to multiply by root 34 top and bottom because that's the equivalent of a 1. So my final answer ends up being 5 root 34 over 34. And will 5 and 34 reduce? Nope. There's the answer they're looking for. All right, example 6. They give us sine of arc cosine of 2/3. Why does this one not have the extra bracket or brace around it? That's because this didn't need a separate one. It was in its positive format, not a negative format, so I can just use the simplified parentheses. Again, you don't need all that explanation just to do the solution. So which quadrant will I graph for the tightest for where cosine is positive? Oh, that would be all. So now our cosine is ca, adjacent over hypotenuse. So the adjacent is 2, the hypotenuse is 3. Do I really need to find the degree? Nope, I want to find the sine. What does sine want? Opposite over hypotenuse. Oh, I better Pythagorean theorem to find the opposite. So 2 squared is 4 plus the unknown squared equals 3 squared is 9. X squared equals minus 4, that's 5. X equals, and as soon as I put a square root around something, I know immediately to put the plus and the minus, root 5. Now when I go to fill it in as its opposite, this is a line. Can a line be negative? Well, it could, but in this quadrant, what should it be? Positive root 5 over the hypotenuse of 3. Do I need to adjust the radical? Nope, it's in the numerator. No problem. We can just box it.